Hello, I'm Jack. Welcome to Practical Programming channel. In this video series, you will learn everything you need to get started with WebGPU Graphics Programming. In the last video, we discussed how to create a C-shell surface. In this video, I will explain how to use the parametric surface data function to create a Sievert-Enneper surface. This surface is a special type of spheric surfaces. The Sievert-Enneper surface can be formed by a thin metal sheet. That is, we can take the metal sheet by its tails and wrap it around the equator of the unit sphere. It will bend into the shape of a sphere, but it is not big enough to cover the whole the sphere. You can try to cover the large portion of the sphere, but the holes are always there. Here is the animation for building the Sievert-Enneper surface. This surface can be simulated with this set of parametric equations. You can see here in u and v are parameters, and x, y, and z expressed in terms of these parameters. The u can take a value from minus half pi to positive half pi. V range in 0 and pi. Here the parameter a can take the value from very small number to 30. Here we will use the git tool to clone the source code used in the last video. Here is the download link at the GitHub repository. From this link, you can download the source code used in the last video. Now open a command prompt window and run the following command: git clone and paste this link. This will generate a WebGPU 30 folder on your local machine. This folder contains all the source code used in the last video. Now we want to change the name of the WebGPU 30 folder to GPU 31. Rename WebGPU 30 GPU 31 and cd into it. cd GPU 31. At this point, we are going to start Visual Studio Code with the command code period. This is a Visual Studio Code interface. Okay, we can close this welcome page. Now, here contains all the source code used in the last video. Now open a new terminal window and run the npm install command to restore the npm packages used in this example. Okay, finished. Now all the installed packages are stored in this node modules folder. Now we need to add the function to the mathfunc.ts file. From the src folder, open mathfunc.ts file. Here we need to add a new function called Sievert-Enneper function. You can see the Sievert-Enneper function here. This function takes u, v, and center as its input arguments. Here, the center parameter lets you set the location for the surface. Inside this function, we set the parameter a here to 1 and we then define x, y, and z as a function of u and v using these parametric equations. This function returns vector 3 point on the Sievert-Enneper surface. Now we can save this file and we can close it. Next, we need to make some changes to the index.html file. From dist folder, open index.html file. First, we need to change this 30 here to 31 because this is 31st video. Here we also need to change the h1 title to Sievert-Enneper surface. Sievert-Enneper surface. The input parameter here we used will be the same as was used in the last video for creating the client portal. But we need to change the default scale Y here to 0.3 instead of 0. Now we can save this file. Next, we need to make some changes to the main.ts file. Open main.ts file from the src folder. Here, first we need to change the mass function from ccell to Sievert-Enneper. Inside this create surface function, we also need to change the ccell here to Sievert-Enneper function. And we also need to set the proper parameters as its input argument. Here is -12 pi to half pi. Here we use a small number, not 0 to pi. Here we use a small number 0.0001 to draw the pale more clearly. Here the UV deviations, we can change it to 60 to 200. And we also need to reset the x and z range change it to 2, -2 to 2. Here we set a scale is 2 and the default scale 0.3. Here is the default parameter. Here scale Y we also need to change to 0.3. Or the other code is the same as that we used in the last video, so don't need to make any change. Now we finish the modifications to the main.ts file. We can now save this file. Up to now, we have finished all the programming. Now we can run the following command on the terminal window to bound our TypeScript code in production mode. npm run prod. Okay, the bound file is created successfully. Now we can click the Go Live link to open the Chrome Canary to view our Sievert-Enneper surface. Okay, here is our Sievert-Enneper surface with default lighting and jet color map displayed on this page. Here the scale let you set the size of the surface. For example, we can change it to 1. You get a smaller surface. Now we can change it to 0.5 to get a better view. The scale Y let you set the aspect ratio. For example, we can change it to -0.2. So we get a long sphere here. Can also change to 0.5. So you get fat and sort sphere. So we can change back to default parameter. Get a better view. Next, we want to change the color map from this drop-down menu to recreate a surface with different color maps. For example, this default jet, we can use autumn color map, bone, Q, cool, Cooper, grays, hot, HSV, spring, summer, winter. So we set back to default jazz color map. Now we have completed this example. Most examples presented in this video series are based on my recently published book, Practical WebGPU Graphics. From this link, drsu.net.com, you can see the details about this book. I have created a GitHub repository to host the source code used in this video series. From this link, you can download the source code used in this video series. I also created a live demo at this link. This demo shows the live results by running the example projects presented in this video series. I will end this video here. See you next time. Bye.